Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Joe, welcome to the show.
Thank you. I appreciate it.
Oh, I'm glad we connected through John Zalar, I believe. And we don't talk electrical power creation or what that kind of power we're creating and what the effect of that power is on systems downstream. Very often, the Uptime podcast, because there's so many wind turbine issues, is mostly focused on mechanical problems. But we're finding that more and more problems may have an electrical origin. And we wanted to get an expert in here, and that would be you, to come help us on harmonics, because there are requirements about harmonics.
There are. IEEE 519 governs the requirements for harmonics at the point of common coupling. That's correct.
And your prior experiences with GE, which is now GE Vernova, down in South Carolina.
That's correct.
But you were involved, maybe give a brief description of the things you're working on, because when electrical people talk, kind of gets lost in translation. You were knee deep, maybe waist deep, maybe eyeballs deep in electrical power at GE Vernova?
No, not knee deep, not waist deep. I was baptized, completely immersed, all the way in. I came shortly after the Enron acquisition. I was one of the electrical engineering managers at the time. We had, I think, 2 or 3 at the time. This was pretty early on. I got out of that because I like management, but I like electrical engineering. So I wanted to go back to being an individual contributor. So I've touched just about every electrical thing you can think of in a wind turbine, and also in solar as well.
You know, a little bit of a sidebar here, because we want to definitely get into this deep technical conversation. But Joe, you touched on something that happens to people, right? You're a really good engineer. You've run a team. You've solved some problems. So now you get promoted to management, but you don't get to engineer as much anymore, right? So you start being leadership and like doing all these things, how to manage people, how to run a team, this, that, and that's great. We need that. The industry, every industry globally, we need to be able to do those things. But for engineers that have engineer at heart, and I'm also looking at you, Alan Hall, they want to be able to engineer, right? They want to be able to do stuff to make a difference, to get hands on with a problem. So you've done that though, right? That's you. You are now Joe Chacon is Padge LLC.
And Padge is short for Padre, which is what my kids and grandchildren call me. They just shortened it from Padre to Padge because saying 2 syllables was too much, and I liked it.
Yeah, I like that. Okay, so like we said, you guys, you're getting deep into harmonics and other issues. You get called in by solar farms to solve problems, and this is the thing Alan and I were kind of talking about off air a little bit. Is we have a bit of a culture like in wind right now of electrical problem, swap apart in, swap apart out. But nobody's looking at the root cause of why did this thing fail, and how can we make this more robust for the future. And that doesn't just stop at components in the turbine. It's BOP, and this is, like you said, also solar and other industrial facilities as well. But that's what you tackle, right?
Yeah. And, you mentioned John Zalar, great root cause analysis guy, does fish bones, 8D modeling, things like that. What your observation that you're seeing, I think, is correct. People ignore one of the fundamental root causes for a lot of issues, not just in renewable energy, but anywhere you have large amounts of nonlinear loading. These days, that's primarily coming from data centers. With the advent of the diode, 6-pulse front end, variable frequency drive, IGBTs, any type of switching device, and it's only getting worse. It will never get better because we are putting more and more nonlinear loads on the utility and fewer linear loads. Even our lighting today, we don't use incandescent anymore. It's all either LED. Well, we used to do fluorescent, but LED is a horrific offender for harmonics. So, and I hate to pick on that technology because they all really are. So a solar inverter, a wind turbine converter, a UPS, any type of device is going to introduce more harmonic content into the grid. So you got the issue where the device itself has harmonic content coupled to a grid that's getting more and more harmonic content already on it. So the situation is definitely getting more and more exacerbated.
So some of those harmonics have really significant consequences. If you go to Padge LLC on YouTube, you can watch some of the discussion there and walk through the equations about what harmonics can do to equipment. On generators up in the wind turbines, you can actually damage some of the Y connections on those defig generators. It causes all kinds of problems. And I know one of the issues and it's being sussed out right now, so we're talking about it live as it's happening, is they're seeing transients come from the line back up into the turbine and are causing problems to the electronics, straight harmonics. And the same thing coming out of some of the turbines is the harmonics can be strong. And in one of your videos, you talked about what kind of damage you can do to a transformer if you have harmonics that are significant enough. It's surprising how you can shorten the life of a transformer.
Correct. Or any magnetic circuit, generators, motors, transformers, anything that's going to take electrical conversions to magnetic conversions and back or vice versa, any type of thing like that. They cause extreme dielectric stress and extreme temperature changes. And both of them are damaging to devices like transformers, motors, generators, etc.
Yeah, because transformers and all that sort of magnetic equipment is designed to work around a core frequency, typically 50 hertz or 60 hertz, depending on where in the world you are. When you put other frequency components on that equipment, it's not designed to do that. So that turns into a lot of heat a lot of times. And then you overtemp or shorten the lifetime of transformers on the pads and up tower in some cases that don't, if you have a failure like that at a wind farm, and I saw it most recently a couple of weeks ago where they're replacing transformers, like, wow, it's only been there a year or two. That shouldn't happen. There are other so those kind of failures, unless you're paying attention, are just going to repeat, right? Because replacing a pad transformer with another pad transformer doesn't remove the source of the problem. It just puts in another fuse in the circuit.
Correct. And, let's say you put it in pick a year, January of 2015, and your harmonic content from utility can change over time. So many times it's worth just taking a look at it. In one of the videos you talked about, I promoted a Fluke 1777 power quality analyzer tool that I use, and I rent that tool out to people that are wanting to do a study. And that's an economical way to do a study. The technician or engineer or whoever puts that in does not necessarily need to know a lot about harmonics to set that up. You're going to be putting in either 3 or 4 CTs, depending upon whether you're a 4-wire or 3-wire system, and then connections to your bus for voltage. And then you turn the Fluke on and you verify that your currents are going in the right direction. So in phase A current, it's phase A voltage, and you start a session, and then you mail it back to me, and I'll give you the report. And it does a lot more than just harmonics. And basically, I run an IEEE 519 report. It does sags, swells, it does super harmonics, it does interharmonics. Super harmonics are harmonics that are higher than 50 times the fundamental. So that's 50 times 60 for 60 hertz people, or 50 times 50 for 50 hertz people. And you mentioned, Alan, that transformers, motors are designed for a certain frequency. If you take a motor or transformer and look at it, it's going to tell you the frequency. Sometimes it's dual rate at 50 or 60. But the engineer that designed that transformer motor is going to take certain things into account related to the magnetic side to make sure that it's able to operate for that broad frequency range. Low frequencies are quite bad. In fact, as you get towards DC, you can't use magnetic circuits as a rule. I mean, there's ways to make DC motors and things like that. And then as you get towards higher frequencies, then like 400 hertz is a common in aviation, it's specifically designed for that frequency. So when you introduce even small amounts, it could wreak havoc over time.
So a question for you, just we're talking IEEE here. Do you get into this is like as a Podge LLC thing? Do you get into more of these studies at the development stage, or is it once they are deployed and having problems? When do they call Joe?
That's a very, very good question, Joel. I do both. So if there's a fixed installation, I could come in and put up the Fluke 1777 and conduct that study for that person or the company, or they could do it themselves and just FedEx or UPS me back the equipment and I could interpret the data. If you're doing a new installation, I use a software called Easy Power. There's others, SKM, ETAP. If you ask me what type of phone I use, I'll tell you I got an Android. Why do I have an Android? Because that's what I'm comfortable with. That's what I use. I'm not opposed to Apple or anything like that. Why do I use Easy Power? Because that's what I use. I mean, you get comfortable with what you use. 20 years ago, I used SKM, but Easy Power, and there's a video on that YouTube series I mentioned about how to use Easy Power to do IEEE 519 harmonic studies before you even put it in. So that can be done as well. And I can model it with Easy Power after the fact too, but Fluke makes it so easy. It's just hook up 6, 7, 8, 9 leads, whatever, click record, come back a few hours later and populates the report. Then when you want to talk about the fix, then I might have to use Easy Power to help with, do you want so there's lots of fixes, and I hope we get to talking about some of the fixes here in a minute.
That's what I wanted to dive into next, because I'm thinking, okay, earlier we talked RCA, how these, what's happening here. And my mind immediately goes to, and everybody that's listening here knows I'm not an electrical engineer. Like, nothing nuts whatsoever. Like I put KC lights on a truck once and almost burnt it down. So that's not my thing. But in my mind, this goes to this unstable grid with a lot of frequency. So I go like, okay, is it a grid macro problem? Like, do we need to have more flywheel type technology on the grid to even these things out? And I'm thinking about, like, I'm in Texas here, right? So there's all kinds of renewables, all kinds of, up, down, up, down, up, down. We talk about duck curves and we can look at a graph. Yeah, that's the entire grid. But when you talk about at the wind farm or solar farm level, there's so much differing load. And now we're adding batteries and we're adding data centers and all that stuff. So there's multiple entry points, I think, to solve this. And one of them is Joe Chacon standing in front of ERCOT and telling them how to fix their problems at a macro level. But I think what we want to dive into here is there's also filters and other fixes from, the ABBs and the Siemens and the Schneiders of the world that can fix things at a local level. So what are some of these problems that you see and then fixes that you prescribe to solve those problems?
Well, I must clarify, it's not a utility problem unless the utility is using massive amounts of renewable energy. With that said, though, whoever makes the wind turbine or whatever the asset is, you're going to be required for the point of interconnect to do that IEEE 519 study. What causes the problem is on the load side, because you have the most classic case of this is a 6-pulse rectifier on the front end of a variable frequency drive. Before the advent of that, people would just put across the line starters or across the line contactors to turn on a motor. And a motor is a very linear device. The only issue you might have with that are dips and swells, or mostly dips for that matter. But when you put a variable frequency drive on there, which is a wonderful, wonderful device, it gives you absolute control over that motor, and you want to put it in all day, every day. But when you put it in, you're going to want to put a line reactor in front of it. And if your VFD is here and your motor is so many feet away from your VFD, you're going to want to put in different types of things as well. And those could be DV/DT filters or sine wave filters ultimately. And I mean, sometimes you can just do a basic choke, but you're going to usually look at a DV/DT filter or a sine wave filter between those two devices. So those are what you're going to do at the source for where you are creating your harmonic content that gets reflected back up onto the utility. So Those are very simple things to do that, in my opinion, are no-brainers. And also use shielded cabling. Um, I, I preach this a lot. Between your VFD and your motor, use shielded cabling. Um, Now, let's talk about if you've got all this in place and you still have massive amounts of harmonic content. What do? I'm in love with the active harmonic filter. This is the best thing since sliced bread. And I don't want to oversell it because my wife says, you talk about it so much that you make me think you're overselling it and I don't want it. And that's not what I'm trying to do here. But there's tons of people, companies that make an active harmonic filter, and that has the capability at the point of common coupling of completely neutralizing your harmonic content. And this is the part that I like the most, power factor correction. So power factor is just basically a ratio of real power and reactive power. You want it to be as close to unity as possible, and that's what the utility likes. So another side effect of excessive harmonic content is also lower power factor when you accurately measure it. So an active harmonic filter is kind of like, I forget which law, I think is Newton's third law. For every force, there's an equal and opposite force to go with it. So if I just push that there, I'm not pushing back on it, right? So if you have let's say you have, I don't know, 500 hertz of harmonic content that's constantly being injected, an active harmonic filter will come in and basically do that. And it will also do it for other frequencies all at the same time, completely canceling them out. It really is a wonderful, wonderful device. And you don't have to put it in series with anything. You put it in shunt. And that means you could get close to your point of common coupling. So on so a point of common coupling, you could define it anywhere. But if you were going to put this in, let's say at a solar plant, you could put this in at the output of the central inverter. Or if you got a string of series, a series of string inverters, you could put it at the switchboard there as well. Um, and it'll neutralize the harmonic content that's there. And even downstream, as you get further and further away from your active harmonic filter, your THDV, that's total harmonic distortion voltage, and a little bit of THDI, total harmonic distortion current, goes down as well. But at the point of common coupling, you are putting the quietus on that and squashing it. It's a pretty cool device. And I don't sell them, but I help specify them.
So it's like it's the ultimate noise canceling headphone for BOP.
Yes, perfect. That's exactly the best analogy. I love that.
So you go on Amazon, you buy a set of Bose 750s, and you put them over the cable, right? Then it's good?
Very, very similar technology. Yes. I love the analogy. I love the analogy.
Yeah, but it's magic because 20 years ago, you really couldn't do that, or if you wanted to, it was super expensive, and the prices come down. They're still expensive, but you're trying to eliminate a more complex problem that you didn't necessarily create, right? So a lot of these harmonics are coming out of equipment that probably did not really meet the spec to begin with, and you're just trying to find an ultimate solution that gets the plant running again. And that's the key here. It's going to save you a tremendous amount of time and effort if you can use active suppression instead of trying to fix the 100 inverters that are creating this problem.
And that's the one thing I want to touch on there. Like if this isn't solved, or if this is an issue and you don't use a certain fix, the failures, what are the components that will fail?
Any and everything. I was, I did a presentation of harmonics a couple of days ago, and I used the Bugs Bunny analogy of the gremlin in the airplane. So in the 1940s during World War II, many of the pilots would say, we have gremlins in our system. And gremlins are kind of like harmonics. They just show up in all types of different places. Even on mechanical devices related to bearings and other things, it just shows power supplies can start going. Motor bearings can start falling. All types of things can start failing.
So let's talk about that. There are a number of main bearings that are failing in wind turbines today that look like they have electrical discharge damage. And the everybody who's designing these systems, these wind turbines, pretty smart, right? There's a lot of engineering that goes into a wind turbine. But when you have undesirable harmonics, regardless of where they come from, could be from a piece of supplied equipment, that those harmonics can show up on mechanical devices like bearings. You can actually pick up harmonics physically from discharge. You'll see discharges to bearings and drive shafts, all the things you wouldn't expect. But here's the one thing I wanted to talk to you about, Joe. Can you kind of like physically see like, oh, that's an electrical discharge, or oh, that's a mechanical failure? Are there differences between those two when it comes to mechanical failures from harmonics?
In cases like that, that's where you want to pull in a holistic RCA approach, kind of like the gentleman, John, we've been talking about before. John is a great systems engineer, and he would help isolate electrical, mechanical, environmental, things like that, and look at the contributing factors that come in to producing all of those things. The answer is yes, it could, but not every time. And it takes a certain amount of surgical precision to diagnose the root cause or combination of root causes.
Yeah, it's one of those Sherlock Holmes quotes, right? Once you've eliminated the impossible, everything else is possible. What is that saying, guys? It's probable. There you go. Right. Where on the mechanical side, it seems like we've eliminated a lot of mechanical probabilities of it could be something in manufacturing, it should be something in tempering, it should be something in coatings. And now we're going down that rabbit hole of, I wonder if this is electrical discharge. I wonder if the brushes are working. Do we need to install brushes? Do we need to add more grounding in the towers to get rid of some of these or provide another path for the harmonics to go through? It is a complex problem, but Joe, if they're not bringing someone like you in to help look at this problem, they're not going to solve it just by eyeballing it.
Right, right. And then finally, the most important consideration of all of this is economics, and finance. Sometimes living with the devil you know is better than the angel you don't know. And you notice I switched that up. Yeah, everything has to have an ROI and a business case. And you can come in and solve this and probabilistically reduce all failures to 6, 7 sigma, but at what cost? So what I try to do is help customers really dig into it electrically. And if you got mechanical devices that are failing, then you're going to want to look at it holistically. In the case of solar and things like that, you don't have a lot of moving parts. So wind turbines a little bit more complicated. But at a facility where you have motors and drives and things like that, um, it doesn't always have to be electrical or mechanical. I became a thermal engineer over the last few years, not because I liked thermodynamics, but because I had to keep my electronics cool. And it was a discipline that I had to really get familiar with. Um, the things related to bearings and other stuff like that, I've known some phenomenal bearing people, loads people through the years. That's stuff I don't understand. But when you bring in a good system engineer and you're able to holistically parse it out, that would be the way to go on those things.
Absolutely.
I like part of this conversation here, Joe, is that, okay, so this resonates with Alan and I because we are talking with lightning protection people every day, right? Like, hey, I have this issue, There's a specific fix or a prescribed fix for a lot of different things that can happen, but it all needs to be based in a business case. If the business case doesn't make sense, or you can't present a decent business case to someone, you might as well just get off the phone. And I think that the wind industry really needs that, renewables industry in general, but the wind industry really needs that if we're trying to, because one of the goals of the Uptime podcast here is to lower the LCOE. If we can help make wind turbine or wind energy more competitive across the globe, beautiful. So the fact that you're approaching business as business case forward, I really like to hear that.
Yeah, that's good feedback. I like that.
So Joe, I know we could go on all day, and if you let me, I will. So we're going to have to invite you back because I think as Joel and I learn more about some of these harmonic problems that exist in turbines and also on the line, we want to talk to you about possible solutions, what you can do about it, how to address it, even how to suss it out, diagnose it.
Related to lightning, I'm sure all the time you're constantly looking at, did the utility cause this? Did the device cause this? Or did lightning cause this? So bringing that harmonic aspect in and utility power quality in general, harmonics is just a subset of the overall power quality. Um, it definitely does help differentiate things from something happened electrically. What was it? That level of knowledge, I think, goes a long way.
Yeah, it sure does. So, Joe, how do people get a hold of you if they need to do a harmonic analysis or just take a kind of a holistic look at what's happening electrically in their turbines or in their solar facilities?
My email is pretty easy. It's josephchacon@podge.org, Padge. My website is podge.org as well. I encourage people to check out the YouTube videos because that's to demystify harmonics a lot and educate people. My goal is if people and technicians and engineers are educated, it helps them become better for their companies. And, I do like making a buck, but more than that, I like seeing people succeed. And I have a lot of people in various industries, not just renewables. I want to give them the tools to be able to do what's best for their companies. And that's what helps me sleep good at night is doing that in education.
So check out Joe's website. It's spelled padge.org. And you can also check out Joe's YouTube channel, the same thing, Padge LLC. Just put it into YouTube and it'll come up. You can watch some of those videos on harmonics. Very interesting stuff, Joe. Appreciate you actually putting that up on the internet. It's going to help a lot of people. So, Joe, thank you so much for being with us today. And yeah, we'll talk soon.
Thank you, Alan. Thank you, Joel.